Data Voyagers.
Time is the most democratic of all data sources. Everyone gets it in the same increments. Second by second, minute by minute, reality unfolds, leaving behind a trail of information. A stock price changing, a heart beating, a sensor blinking, a shopper clicking buy. Each event on its own is nothing, but together they form a rhythm, a pattern hidden in plain sight. And once you learn to read the rhythm, you can glimpse what's next. Welcome to the Data Voyages podcast, navigating the story behind the numbers and the heart of today's journey. We are venturing beyond the event of horizon into the world of time series, where data isn't just a collection of values, but a story told through time itself. From the humble origin of statistical forecasting to the rise of deep neural networks and click predict multivariate time series capability, we'll explore not only how these systems work, but why they matter scientifically, practically, and why not philosophically. So, fasten your seatbelts, fellow explorers, because today time is not the fourth dimension, is the data set. I am Igor Alcantara. Oi, pessoal, and I'm here with my friend, fellow Click ambassador, and co-host of these podcasts, Angelika Klidas. Hi, Angelika. Thanks for meeting me here at the same time coordinates.
Thank you so much. Hoi, Igor. En hi allemaal. Welkom dat jullie er weer zijn. En fijn dat jullie er vooral weer zijn. Igor, let's go.
Let's go. We have a great episode for you. But before, just a few reminders. I'll ask you, everyone who's listening to this, to subscribe to the Data Voyages podcast. How do you subscribe? So you open whatever it's your favorite audio app in your phone. Let's say Spotify, Overcast, Apple Podcasts, whatever app you prefer. You search for Data Voyages podcast, and then you click either follow or subscribe. Each app has a different naming convention, but anyway, and follow us. That help a lot in our statistics, and then it will make sure you all receive the every single episode as soon as we publish. And while there, give us 5 stars. That also help us. And also follow our page on LinkedIn. So you go to LinkedIn and search for Data Voyages. You'll find us. You'll see our logo. Visit our website and online store at datavoyages.net and support us in any way you can by sharing, liking, commenting, all of that. And talking about support, let's hear a quick word from our sponsor, IPC Global. This episode of the Data Voyages podcast is brought to you by IPC Global. This, I think I have that twice. Sorry, let me go that again. This episode of the Data Voyages podcast is brought to you by IPC Global, where data meets intelligence. From predictive models to time series forecasting, IPC Global has everything your company needs to succeed in the world of AI and machine learning. As an award winning Click Elite partner, we help organizations transform complex data into practical, actionable insights using the power of the Click platform. And if your team is ready to level up, our Citizen Data Scientist training program is designed to empower professionals of all backgrounds, turning curiosity into capability and spreadsheets into smart predictions. Whether you're forecasting the future or just getting started with AI, IPC Global gives you the tools, expertise, and education to make it real. Learn more at ipc-global.com. All right. Hi, Angelika.
So that's cool, right?
Let's get
Yeah.
started. So this episode is about time series. So can you let us know what is time series?
Well, Igor, time has always been humanity's oldest data set, right? Long before spreadsheets or sensors, our ancestors stared at the sky, marking when stars returned to the same place. And they noticed that tides rose and fell with the moon, crops grew and withered with the seasons, and that everything living thing moved to a rhythm. Um, those first celestial observations were the birth of time series analysis, long before that. And at its simplest, I should say that correctly, a time series is a sequence of data points measured over time, a trail of breadcrumbs left by reality as it unfolds. And each observation is not an isolated dot, it's a frame in an ongoing film. Watch it closely enough, and the movie reveals its plot. And therefore, unlike statistic datasets where each record stands on its own, like a list of customer ages or countries or products, time series data carries memory. And every new point knows something of that came before. And that memory, that continuity, gives it the predictive power. But if we go back to the mathematical terms, we say a time series is temporarily dependent. The current value depends on the past. So, for example, if yesterday's temperature was 95 degrees Fahrenheit, it's unlikely that today it will drop to freezing. Or if sales surged last weekend, you might expect some aftershocks on Monday. This dependency is what statisticians calls autocorrelation, and it's the heartbeat of every forecasting model. To grasp this intuitively, think of tossing a pebble into a lake. The ripples spread outwards, and each wave influencing the next. And that is what happening in data too. A marketing campaign, a policy change, a viral post, each creates ripples through time that slowly fade or amplify, depending on the system's nature. A time series tries to measure those. Uh, they shape frequency and amplitude, so that when we see them begin again, we recognize that the pattern and anticipate where it leads. So, but here's what the magic begins. Time gives structure to chaos. I like that. You taught me a lot about here, chaos theory, game theory, and so on. And structure is what we need in the chaos, right? This data set without any timestamp. It's just noise. It doesn't say anything. When you add time and patterns, peaks that appear in December, sudden shocks followed by recovery, long, slow drifts, signaling that change beneath the surface. So time transforms raw data into storylines. And each storyline comes with its own grammar, trend, seasonality, and residuals. The structural, cyclical, and chaotic elements that together form the rhythm of the world. Time adds memory, inertia, and causality. It insists that the past matters. Imagine an analyst who looks only at his monthly sales numbers and tries to draw conclusions. They might miss the bigger temporal context, the build-up over weeks or the build-up over months, the holiday season approaching, the slow decay of demand afterwards. To truly understand what's happening, we must respect the sequence, not just the values. And that's, guys, the essence of time series thinking. Order matters. Every data point is a note in a melody, meaningful only when heard in sequence. And this is why time series is often described as the physics of data. Like Newtonian mechanics, it assumes continuity, that what happens next depends on what just has happened. And like quantum mechanics, it admits uncertainty. We can describe the probabilities of the next outcome, but never know it for sure. That's what I always teach to my students, Igor. When you predict, it's always wrong. Never assume it's right, because we have that frequency where we have to work with. So if we zoom out far enough, Almost everything in analytics is a time series in disguise. Customer churn is time series. Website traffic is time series. Machine failure, patient vitals, rainfall, energy demand, all our systems evolving through time. In fact, the very act of measurement implies time. To measure something twice is to acknowledge change. To measure it continuously, it's to acknowledge rhythm. And that is why time series is not a subfield of data science, it's the spine of it. Without time, data is just a still photograph. With time, it becomes a movie. But what truly elevates time series from a mathematical curiosity to a predictive powerhouse is how it captures dependencies across time. For example, the number of flights departing an airport today might depend on last week's bookings, yesterday's weather, and even tomorrow's forecast. Because airlines adjust schedules in anticipation of storms. That backward and forward interplay that is what is occurring where the past influences the present and the future shapes decisions made today, that makes time series analysis uniquely suited to understanding complex living systems. So when we say time series, we're just not talking about sequences of, we are talking about temporal intelligence. The ability to think in time, to detect rhythm in randomness, to find continuity in change. Because in a world driven by volatility and data overload, the most powerful insight isn't what happened or even why it happened, but it's when it happened. And Igor, that's the short introduction into time series analysis. I have been working with my student for time series analysis already for a few weeks, and I'm super interested in the history of time series. Can you help us with that?
Yes, and I love when you said it, that when you have like data without time is like a photograph, but you add time, then you have a movie, which is great. But then with the question is like, how did we get here? Well, because time series analysis, much like time itself, didn't appear like fully formed. It evolved slowly with method across decades of observation, mathematics, and human curiosity. So let's do some little like storytelling. So a story begins once again with the stars. Really? Oh yeah. Before there were databases, there were astronomers. They were the first time series analysts, though they wouldn't have used that term. They didn't say like time series analysis. So centuries ago, astronomers they talk about the heavens, recording the position of planets and stars, and night after night after night. So they notice, oh, look at the star here. After some time, like a few days, few nights, it moves. And then after a certain number of days, it's back to the same position. So there is a certain rhythm. So they notice cycles, the recurrence of eclipses, the periodicity of comets, the rhythmic dance of celestial bodies. So curiosity started the whole thing. So those early observations birthed not only astronomy, but also the mathematical language of calculating periods, the periodicity, like sine waves, cycles, harmonics, that would later become the foundations of time series modeling. So it started way back. Now, let's fast forward to the 19th century. So, what we have in the 19th century is the Industrial Revolution, and that filled the world with data. So, we had like barometers, stock prices, ship logs, agricultural yields, actually, stock prices, which started in the Netherlands, as you know, because of the tulips market. So, humanity was no longer just watching the sky, was watching itself. So we began to notice rhythms in trade, in climate, in production. Economists like William Stanley Jevons speculated that even economic crises might follow solar cycles. Of course, it was pseudoscience back then for sure, but it reflected something profound. an intuition that time has structure. Then came the mathematicians. Like in the early 20th century, people like George Udny Ewell, and I will mispronounce every single name because I'm terrible with pronouncing names. Eugene Slutsky, and later George Box and Gwilyn Jenkins. So they turned that intuition into science, pseudoscience into real science. So they built the foundations of modern time series analysis, not through cosmic observations, but through code precise mathematics. Their key insight was elegant. You could model time dependent processes using only their past values. What? Yes. So that meant you did not need to know how the physics of the system work. You could infer its behavior statistically. So that was the birth, what we call the ARIMA model. What is ARIMA? Auto-regressive integrated moving average. That's like a long, ugly name, but let me like break it down. Auto-regressive integrated moving average. So it's auto-regressive because the present depends on the past. It's integrated because trends can be different out, like differentiate calculus, to find stability. And moving average because noise itself has a memory. Like things, good or bad, they accumulate
Yeah.
over time. So it was a
And this
breakthrough.
is really,
Go ahead.
this is really an older model, right? As you said, I know my student.
Oh yeah,
You
very old.
he worked with he actually they chose the Arima model because of of its accuracy. So if it's that old already, it's still one of the best models, as he said.
Oh yeah, no, there's some old
Do you
statistical
agree?
techniques that we still use it. Yeah, there's some, but I
Yeah.
mean, it's limited to a certain conditions, and I'll explain that. So it is limited to certain like conditions, which I will explain soon. But yeah, I mean, it's still being used in a lot of scenarios. So
Mm.
it was a breakthrough because suddenly statisticians could predict stock prices, rainfall, factory output using only past observations. So with small data sets, then we can have great accuracy in predictions. So the technique became so influential that Box Jenkins, one of the mathematicians that I mentioned, became shorthand for rigorous. So the data for rigorous data-driven forecasting. So for decades, ARIMA and its cousins, like those variations,
Yeah.
rule the forecasting world. So, but while statisticians refine equations, something else was happening, something cultural. Business, governance, scientists began to realize that time series forecasting wasn't just an academic exercise, it was also power. Predicting the future meant anticipating demand, avoiding losses, optimizing production. It was a strategy disguised as mathematics. Imagine the power of that. So by the 1970s and 1980s, the field matured. Economists introduced the VAR models. VAR stands for vector auto regression, for handling, in that case, multiple variables at once. So weather forecasters incorporated satellite data, creating complex multivariate systems. And I'll explain what a multivariate is. We'll explain that during this episode.
Yeah.
Time series moved from backboards to mainframes, like computer mainframes. Then, as computer advanced, the next wave arrived, which is machine learning. So the 1990s and the 2000s introduced models that could learn patterns rather than just being explicitly programmed. So instead of asking, what equation fits this curve? We began to ask, what system best predicts this sequence? So it's a much more complex kind of question. So that subtle shift in mindset from initially modeling to now learning change everything. So then, fast forward a little bit,
Yeah.
let's came 2017, a year that, deserves a footnote in the history of both AI and time series, and is the
Yeah, I believe
release
that
of
was
very important. Go
yeah.
ahead.
Sorry, Igor, for interrupting. But I believe 2017 was the end of the last AI winter, as they call it, right? And it started suddenly to grow with Rapid Miner, R, and everything, right?
Yeah, yeah, around that. I mean, there was some earlier developers a few years before, but
Yeah,
2017 was the like one of the biggest revolutions in AI development. With the publishing
of that.
of a paper, yeah, paper was a partnership between like some Google researchers and the University of Toronto. A paper called "The Attention Is All You Need." It's
Yeah,
kind of a joke with a Beatles songs. All you need is love, so attention is all you need. And that paper introduced the transformer architecture. And if you want to know more
yep,
about the transformer architecture, about that paper, I do have an article that I wrote. The title is actually "Attention is All You Need" in the Data Voyager. So you go datavoyager.net, you find that. I think this is what, like maybe a year ago or so. So you need to scroll down a little bit. And also in our YouTube channel, Data Voyages, there is a video about the same article. But if you go to the blog, I have also the link to the video. Anyway, introduce the
that's great.
transformer
Yeah,
architecture. And the transformer architecture is the foundation, is the base for all of the LLM models like ChatGPT, Gemini, Claude. They're all based on the
hmm,
transformer architecture. So basically, through designed language translation was what they initially University of Toronto. So basically, the initial exercise was translating English to French and vice versa. But then transformers very quickly, found a second home in forecasting, other than language itself. After all, what is a sequence is not a time series of words. And what is a time series is not of language of events. So they kind of are very correlated. So deep learning architectures like the LSTM, this is actually beautiful architecture, and that stands for long short term memory, and GRUs, which are gated recurrent units, were already revolutionizing how we handle sequential data, from speech recognition to predictive maintenance. But transformers changed the game again. They could look across vast history of data and selectively attend to what matters most. They didn't see just sequences, they saw relationships across time. And that's one of the biggest revolutions in that, that story. And that's when multivariate time series truly came alive. I mean, it already existed, but now it truly gave a different kind of power, because now
yeah,
you could model not only how one variable evolved, but how many evolved together, how temperature affects demand, how social sentiment moves market, how one system's rhythm echoes in another. And now with tools like Click Predict, which like recently launched a time series forecasting, those methods are not just confined to data science labs anymore. They're coming to dashboards, to business users, to everyday analysts who may not know what a covariance matrix is. They don't have to, but who deeply understand the rhythm of their businesses. They understand that kind of as an intuition natively. So the next democratization of forecasting is taking what's once required a PhD and putting it at the fingertips of anyone who can ask a good question. Now, Angelika, I
hmm,
mentioned like a few terms like univariate, multivariate. I think it would be a good idea to like explain what
yeah,
they are and what is the difference.
yeah, yeah, yeah. It's very interesting what you just told us. I told you the story about my student. He examined how they said researched time series models, various ones like Arima, like uh, Chat Time, and so on. And then I learned from that moment on that even the large language models that can break it down into its up, its middle, its down, and so on. That you can actually also predict time with large language models. It's very interesting material, Igor. So let's continue with that univariate and versus. So picture a single heartbeat on a monitor. It goes thump, 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 thump. And that is a univariate time series, one variable evolving through time. You can see its rhythm, detect in regularities, whoa, a difficult word for me, and even forecast the next beat. But when we use it with other things like watching that heartbeat alongside oxygen levels, blood pressure, brain activity, suddenly the story expands. You're no longer seeing just the rhythm, you're seeing life. And that's what it's all about. And that is what we call multivariate series. And it's the difference between listening to a single note and hearing an orchestra. So let's start simple. Univariate forecasting is very elegant. It studies one variable and it assumes its past holds all the secrets of its future. Like ARIMA, what you just told, or exponential smoothing live here. They look backwards to look forward, finding seasonal patterns, trend, and noise. And I know, as a matter of fact, from that study, that ARIMA is very good in. Think of daily coffee sales in a cafe or a temperature in your city. The data is one dimensional and the question is direct. Given what I know about yesterday, what is likely to happen tomorrow? It's the approach that powers decades of economical forecasts, weather predictions, demand planning, and in many cases, it works just beautifully when the system is mostly self contained. But the world rarely is a univariate model of a variable depends only on itself. That sales depend only on past sales. That temperature depends only on past temperature. That markets move into isolation. Reality, however, is a web of interactions, not a line, but a network. Now imagine in your chart can feel the gravity of the others, where variables attract, repel, and orbit each other. That is multivariate time series forecasting, or MTS as we call it. In We acknowledge that no variable exists in a vacuum. Sales is influenced by marketing, the energy consumption is influenced by temperature and even by season. Hospital admissions are influenced by air quality, or like COVID we had, the pandemic. Traffic congestion is influenced by water, weather, time, or day, and even the previous day's accidents. Each of relationships bends the trajectory of the Earth, just as a planet distorts the space-time fabric around them. And the mathematics of this reflects its complexity. Instead of a single column of data, like sales over time, we now have multiple temperature, promotions, holidays, social sentiments, and competitor activity. And each variable has its own rhythm. Yet they share a timeline. Together they form a matrix of sequences, each influencing and being influenced. And that means that forecasting isn't just about temporal correlation anymore, it's about cross variable correlation. You're not asking, what does the past say about the future? You're asking, what does everything else say about it? So, if we go back to the orchestra metaphor, each instrument, each variable plays its own melody. But when they play together, harmonies emerge. Some notes amplify each other, others create tension. Understanding the system means understanding not only the notes, but relationships between them. Um, Mathematically, this is where models like VAR, the vector autoregression and structural equations models, SEM, first try to capture those interactions. So FAR models, for example, let multiple variables be an autogressive together. Each variable current value depends on past on it, not only on its past, but in the past of others as well. And that was in the 1990s, the version of symphonic thinking. But the symphony became more complex time. When we did forecasting projects for healthcare here we used Rapid Miner and we only looked at the number of patients entering an ER and it learned from its past. So it was a very simple thing, but it became more complex when we added data like weather forecasting and so on. Do people more hurt themselves when there is ice on the road, or there is snow, or there is a lot of wind? So we could see even more. So that was creating a symphony, and it which started simply on its own and became bigger and really an orchestra of amazing things. And we were able to predict the number of patients based upon several reasons, but also predict the money streams that we could forecast a system. So it was amazing. Um, but then, when you have that symphony, when you have that moment, it will become more complex with time, right? So we have the Granger causality, and A actually help predict variable B. For example, does social media activity Granger cause stock market movement? Um, does temperature Granger cause electricity consumption? It's not true causality in the philosophical sense, but it's predictive causality, and that distinction changed the economics forever. So, and then again, the models evolved. Computing caught up, and we had that speed and that memory and everything what is happening, and it's even better now. Deep learning entered the stage. Models like Deep are temporal fusion transformers, TS mixers, Tide. It became to capture a relationship that no human equation could easily describe. They they learn not just lag and lead effects, but nonlinear, context-dependent, shifting relationships, and the kind of complexity that defines the world that we live in, the real world. And that deep learning moment, Igor, that is something that you are going to talk about, the revolution of deep learning.
Yeah, that I think I mentioned this before, like deep learning neural networks, that kind of thing. It was actually my main focus of study when I was doing my master's,
Mm.
and so that's kind of a topic that is kind of
Into
my
your
favorite
heart.
one. Yeah, it's
Yeah.
into my heart. It's one of my favorites. When I went to medical school, neurology, neuroscience was the thing that I was most interested in. So that I kind of like that. So embrace yourself. But let's go. So for decades, forecasting the future meant basically walking a straight line. So you look at the past, draw a trend, added some seasonality, sprinkled a little noise here and there, and extended the line forward. It worked. Simple word. It worked to a certain degree until the word started to curve. Suddenly, we have more data, more complexity. Linear models were not enough. We needed models that could remember, adapt from chaotic data, models that could sense not just repetition, but also meaning.
Meaning.
So that's when deep learning entered the story. So traditional time series models like ARIMA or VAR that we mentioned a couple of times already are rule based. So they're based on rules. So they describe relationships we already understand. Deep learning flipped this idea. What if instead of defining the rules, we let the system learn from the data itself? So we don't define the rules, give the data, let the system figure it out. That shift was huge, enormous. When Box and Jenkins gave us equations, Deep Learn gave us intuition. And I know I'm being a little bit of philosophical here, but it actually what it meant. So it could look at complex, non-linear, high-dimensional data and extract patterns that even experts couldn't articulate. There were hidden patterns that, like business expert, could not actually understand. So the architecture that made this possible was the RNN, recurrent neural network. So they was designed specifically to handle sequences, which basically time series is a sequence. So in a
Yeah.
standard neural network, inputs are independent. like photos, like different pixels and layers of colors, they're independent. But in time series, each input depends on what comes before. So RNNs solved this by looping information through time. The output of one moment becomes part of the input of the next, like a network, neural network. It was a breakthrough, but it wasn't perfect. Imagine you're reading a book where you can only remember the last sentence. You will lose the plot quickly. That's
Mhm.
what early RNNs did. They were great at capturing short term dependencies, the recent past, but they struggle to remember long term ones. So, if a pattern reappeared after a long gap, the networks had already forgotten about it. So then, in the mid 1990s, two researchers, Sepp Horkenreiter, and I will probably mispronounce that, and
No, you did
Jungen
it
Smith.
quite well.
Oh, all right. And Jungen Smith they solved this. So they invented the LSTM, long short term memory, which is actually a neurology terms actually. So that's a brilliant, um, very nice piece of engineering. If you guys like Google those two names, and you can actually read the original paper, there's a lot of math, a lot of calculus, but it's a beautiful genius piece of paper. So anyway, um, so they engineer this theory that gave neural networks the ability to remember relevant information for long stretch of times. Relevant information. This is a key word. Otherwise, it would be like extremely slow. Yes, you need to focus on what is actually relevant. So anyway, think of it as the machine equivalent of selective memory. Like remember what it matters, forgetting what it doesn't. And
Mhm.
LSTM contains what we call gates. What are gates? Gates are, let's say, mechanisms that decide whether to keep or to discard information at each step, which actually our brain does that a lot. It's called the attention mechanism in our hippocampus in our brain. Anyway, it's like a time traveler choosing which moments to hold onto before jumping forward. So, and suddenly, time series forecasting became storytelling. Models could now understand narrative, the cause and effect threads stretching across time. So, around the same time, another neural architecture was taking the world by storm. And one of my favorites, CNN's convolutional neural network. So originally designed for image recognition, still amazing at that job. CNN scan data through sliding windows that they call filters. So they detect local patterns, edges, textures, shapes, etc. So it didn't take long for data scientists to realize that time is just another dimension. I mean, I knew that way before, but then, we just
Mhm.
took us a little bit more time. Anyway, so they started using CNNs to scan time series the same way they scan pixels in an image. The filters began picking up patterns like sudden peaks, periodic fluctuations, or repeating anomalies, local temporal structures that traditional models couldn't actually see. So, in essence, CNN convolutional neural networks taught machines to see time. So, they were designed to see images, but also they taught machines to see time the way we see patterns in space. So, when you combine CNNs, convolutional neural network, with LSTMs like long short term memory, you get a system that can perceive both local ripples and large term waves. So that's the equivalent of hearing both the drum beat and the symphony. And then everything changed again. I already mentioned 2017, the paper "Our Attention Is All You Need," that revolutionized many fields in statistics and AI. In that, when we introduced the transformer architecture. But let me talk about something else than the transformer. The same paper talk about something more profound than that. It's called attention. Actually, the attention is the foundation of the transformer architecture. So attention allows a model to decide which part of its input matter most right now. So if you're reading this sentence, your mind doesn't weight every word equally. You focus on what's relevant to your current understanding. So transformers do the same. They dynamically focus on the parts of the sequence that are most important to the current prediction. So if I say the dog was hungry and the dog saw a food and ate it, you know that eat, what is the attention part? So you know that refers to the food, not to the dog, things like that. So anyway,
Mm.
um, in time series forecasting, that means that model doesn't just look back in a fixed number of steps, let's say a fixed number of days or weeks. It looks across all history, deciding which past moments are relevant to the present. It's not remembering everything, it's remembering intelligently. So this concept
Intelligently.
mirrors Einstein relativity. Like time doesn't flow in a uniform way. Its relevance stretches and compresses depending on context. So transformers are, in a sense, relativistic models of time. So they understand that not every moment carries the same gravitational pull. So that's why temporal fusion transformers, TFTs, is another architecture, become the state of the art for multivariate forecasting. It's like the one of the most amazing models for time series we have, multivariate time series we have. So they combine the power of attention with the ability to interpret results, and they like identifying which variables at which times were most influential for the target you're predicting. So it's forecasting, but built-in explainability. A model that not only predict but tells you why, which is important. A model that is a black box is almost useless and is dangerous.
Mhm.
So as deep learning
Because I think
evolved,
it's, yeah,
specialized.
it's very important. Sorry, Igor. It's very important to understand why things are happening, in our data world.
Exactly. You
Can
need to know why why
you
why
help?
I'm
Can you help?
recommending. Go ahead.
Now, why you are recommending? I mean, to do you have some kind of how do you say it in English? Some is about a model that only predicts but tells you why. Did you use it somewhere in your line of work? How
It
does
doesn't tell you why. No, I
examples?
mean, I do have examples, not time series related, but not that I've used, because I have something that is important everyone to have: ethics. You don't use something you can explain why. You don't do something you can explain. But there was a very
Yeah.
famous case where I believe it was in Dallas. So the school district of Dallas, they have like this AI system. Basically, we're evaluating the performance of their teachers of the various schools, and then based on the model, they got like a few of the bottom teachers, and they let them go. They fire them to hire new teachers. But then one of
Mm.
these teachers, she asked, "Okay, why was fired? What is the like the score, specific points, the specific like aspects in my review that she was never interviewed for an actual review, as far as I know, that and then was the worst that I have to improve." And they said, "Well, I don't know. The model gave us this number. All right, can you explain the number?" No, we can't. It was a black box. It was a neural network. There was no explainability.
Mm.
So of course she filed a suit, and then of course she won because as if something so critical, you just don't rely on a machine without
No.
understanding why. Human has to
No.
take the responsibility. So that yeah,
Yes.
so it is very important to
Well,
have
it's
this
a good
responsibility.
story.
Yeah.
It's a good story. Yeah, it's a good
Mm.
story. What can go wrong?
Oh
So
yeah.
ethics, transparency, responsible AI is super mega important.
Absolutely,
Uh,
absolutely. And it's more than ever, and it will become more and more as AI evolved. But now
yeah.
back to our back to our story. Each one of these different, so I mentioned like different like architectures that came after 2017. So each one of them approach time differently, and each one will be better suited to a different kind of problem, a different kind of prediction. It's like
Mhm.
distinct philosophies of how you perceive the flow of events. So there are models like Deep AR, Tide with time series dense encoder, TX mixer, temporal fusion transformer TFT. That you mentioned some of these. Each of these models represent a different way of experiencing time. For example, Deep AR listens to the rhythm across multiple entities. Tide observes the grand arc of history. TS Mixer zooms into the interplay between moments and variables. TFT watches time from above, attentive, selective, precise. I'm not going to explain each one of these modules in detail because through
That was
audio
my
it would be hard. But
question. Yeah.
I'll not. If you guys want to know more, I'll not let you hanging. There is an article that I wrote a few months ago on Data Voyagers, datavoyagers.net. It's about time series. So you'll see the article about time series. It was when Click announced that time series will coming soon to the to Click Predict, and then I
Hmm.
decided to explain all of this. And I know these are some of the four of those other algorithms that Click uses. I got some like inside information as an ambassador. So I wrote and
Ooh.
explained which one of them in anticipation to time series launch a few
Yeah.
months later. So you can check on datavoice.net the article, and then I explain using a lot of like relativity, black holes kind of metaphors to explain the concept. But anyway, now that we understand these architectures and all of that, let's talk about something more like real world. Let's talk about some use cases.
Yeah. Thank you, Igor. It's so intriguing to listen to the history and how things evolved over time, but even that the older technologies are still very powerful. So thank you for that. Well, if we look at some use cases, every technology reaches a moment when it stops being about the tool and starts being about the transformation, right? And for time series forecasting, that moment is now. Because forecasting isn't really about predicting numbers, it's about preparing for consequences. The point of seeing tomorrow is not to admire it, it's to change. And deep learning gave us the instruments, and Click Predict gives us the orchestra hall. But the music that played every day in retail, energy, healthcare, finance, manufacturing, and beyond, anywhere time flows and data follows. So let's explore some of the time series moves from a mathematical, we will grow into the practical foresight. So how it becomes not a curiosity, but a compass for an organization, for a person. So when we are in retail and when the future walks through the door, those retailers have always lived by the rhythm of time. Weekdays, weekends, holidays, seasons, promotions, slowdowns. And at a store's heartbeat pulses through foot traffic, transaction, and shelf turnover. And traditionally, managers forecasted sales with intuition more in the weekends. We always do more on the Saturdays than the Sundays, and they use spreadsheets for it. But modern retail generates oceans of time series data. Point of sale, transaction by minute, inventory by SKU. That is, um, help me with the term SKU. I don't know
It's
it
like
in.
SKU is like an item number.
Yeah, yeah. You have an SKU. I know there is. You can say it. I forgot how it is mentioned by location, right? I have a customer, a retail company, and they have stores all around the world. So it's very important that they do things on time, but also in their own stores that the POS systems calculate what's how many people passed the counter to pay, what articles were sold, what is the highest performer, and so on. And then for also you need to know your stocks, right? So the inventory is very important. But also on websites, online clicks, searches, and chart abandonments. Who left my selling website? Who made the online clicks that much, right? What did they search for? Which terms did they use? But also marketing, we have budget for marketing. So how much did we spend? But also the of doing that campaign. We need the customer reviews, ratings, and every social sentiment. And the question: what will we sell? What will happen tomorrow? But what combination of factors makes that happen? Combination of it all so that our sales can go up or that we have more clicks and so on. And that is exactly the point where multivariate time series shines. By bringing together marketing spend, weather data, regional events, and competitor pricing, click, predict that drive demand. And I really love click predict. What is coming? I read a lot about it. I haven't used it yet, but I know we are going to activate it in our office. So umbrella sales will spike not when the rain but 36 hours before, when the weather forecast hits local news feeds. That is a relation, right? I believe the causation, right? How would you explain that? So we have a weather prediction. We will have a lot of rain, and 36 hours the sales go up. Help me with that, Igor. You are
Um,
nodding. Can you hear me properly?
yeah. So, what would help you with what exactly the?
Yeah. Okay. Let's stop for 5 seconds.
Mhm.
So, Igor, uh, help me. How we call that? That one thing depends on the other. We have a name
Oh,
for that.
correlation.
Causation,
Correlation. Yeah.
correlation, right?
Yeah.
Because
Causation. It's
correlation,
yeah. It's a
yeah.
little
So when
yeah.
we know
Uh,
the more complex to explain, right, to the public. But correlations are very important. For example, I do when I do my trainings, and I have this strange trend line, and then it says that eating ice creams and the more deaths in with sharks for of funny things. That's a spurious correlation, right? But this could actually be a true story, right? That we know that the weather forecast says it's going to rain, and we see the spike in our sales for umbrellas. Or, well, again, ice cream sales with temperature alone, but with a 2 day lag after heat waves begin, right? So that's the correlation that we are trying to find. And there are many more to find. And you need to think of that from a business perspective. You need to think in those ways to actually use. And in Click Predict, this foresight doesn't stay in a spreadsheet. It becomes an interactive forecast on your dashboard, color coded by confidential intervals, enriched by variable importances. The result, at the end, the marketing teams know when to launch campaigns, supply chains know when to restock, and managers stop reacting, they start anticipating. Retail time series is where forecasting becomes a choreography. That's it. Aligning the movements of customers,
choreography.
suppliers,
Yeah.
and markets. Yeah, choreography. And they align the movements of customers, suppliers, markets into a synchronized dance with time, because time matters, right? Go to the energy market, predicting the pulse of grid. If retail has rhythms, energy has seasons, literal and metaphorical. Every hour of homes flick on light heaters and devices. Even I do here. I have my lights on because it's dark here already, and I have my heater a little bit on because it's a little bit cold. And each action is tiny, but together they create waves of consumptions that ripple through the grid. Understanding those ripples is not about efficiency, it's about stability. In energy forecasting, the stakes are super high. A misjudged surge can overload transformers. A mistimate supply plan can cause outages for costly overconsumption. Time series forecasting, especially multivariate, is now the central nervous system of modern energy management. So if you look at the variables that can happen, it includes temperature, humidity, wind patterns, probably from data, historical load profiles, calendar effects. Is it a week holiday? Is it during the week? Economical activity levels, generation forecasts, so solar radiation, wind speed, and so on. So, and these data sets together form one of the most complex temporal ecosystems on the planet. Clicks predict time series capability can model these interaction, helping energy companies forecast consumption at multiple levels by region, by customer segment, or even individual meter. And the result, we have smarter load balancing, optimized resource allocation, and early detection of anomalies that hint at a system stress. Forecasting becomes not a report, but an early warning system. I like that a lot. An warning system. It's a kind of predictive radar for the grid. And when you visualize it in Click, the data really feels alive. It can tell a story. It's a digital aurora of demand and supply flowing in harmony across time. And then when we move over to the use case of healthcare, when every second counts, a few domains embody the urgency of time better than healthcare. Here is what forecasting, it's not about efficiency, it's about survival, it's about life and death. Every heartbeat, every oxygen reading, every medication event generates a data point in time. When viewed individually, they are medical records, right? But the combination of it all, when you connect them through time, they become signals, patterns that whisper about what is might to happen next. And multivariate time series forecasting allows hospitals to anticipate patient needs before symptoms escalate. By analyzing the vital signs, lab results, and medication data in real time, models can detect subtle deviations that precede critical events. For example, Click Predict could learn that a patient's oxygen saturation tends to drop to several hours before a sudden, or that ICU admissions rise predictably 2 days after an influenza surge in the ER. Outside the hospital, time series help to manage logistics, predicting inventory of blood units, vaccines, and medication based on seasonality, population density, and historical outbreaks. I know you did a lot in healthcare, Igor, so probably I will ask you a question. Uh, but perhaps the most transformative impact, I think, is public health. Epidemiologists now use time series to track and predict disease spread, like we had with COVID, right? You were very busy with that, predicting things, and you took data as I did here in Europe from everywhere to see what was happening, to see the flow of data. And I wasn't able to program it on my own to have a good data model or do the predictions, but we could see what was happening, and we learned from the past. In my team that we worked, but you did a really huge amount of predictions, right, Igor?
I did. So we did both for United States. So we got the data from the John Hopkins data, and then we use that data basically to predict the number of cases for every single county in the United States. And then I did in
Mhm.
parallel to that, I did a similar work, also using time. I used time series for that. I did a similar work for a nonprofit in Brazil, and we even got some funding from Google, so we could do like a chat bot. It was even like before using the
Mhm.
ChatGPT, any of that. We kind of do a lot of like hard coding stuff, but even did a chat bot for WhatsApp in Brazil. This is all in Brazil as well. So, and we did forecasting to predict for every single municipality, for every single town in Brazil, for the next 14 days, day by day, how many cases, new cases were expected, how many deaths were expected for every single town. Of course, very small towns, the margin of error is a little large because it's a small sample. Bigger towns, like we had like an extremely low margin of error, and we're predicting day by
Yeah.
day to 14 days in the future. And I was running this
Wow.
model every single day and auto generating, and we're using
It's
Click to visualize the data. I'm using a lot of R programming in the back end to calculate
of
this.
course.
Um, it was before we had Click Predict. And yeah, it was a lot of work, but it was, I would say, not something that I took pleasure, because we were basically reporting people dying, and that was terrible. Even with that, actually, that work started with a nonprofit just at the early of COVID. There was no reliable tests for COVID early on, so we develop like algorithms using convolutional neural network that get X-ray images and then predict that we know I was using before to predict pneumonia, to predict COVID as well. And then I had to manually label 3,000 X-rays from Italy. It was one of the first like outbreaks was in Italy, and basically manually labeling them COVID, no COVID, pneumonia, etc. And then I spent like a full like Saturday looking at a lot of X-rays of people who died, a lot of them, and it was really
Wow.
depressing. It was really depressing.
Yeah.
But then,
Yeah.
on the other hand, be able to help people, to inform people, and also to help people with the tools so they can basically come back to the authorities and say, please do something. It was actually
Yeah.
really rewarding, in a personal sense, of course, because I mean, it was a nonprofit. I didn't make
Yeah.
any money from it. Actually, I spent some money. But yeah, so there's a lot of work and a lot of time series work back in the day. I hope I never had to do that kind of work again,
Mm.
because because of what
No,
happens. I don't. I have
let's hope so.
never. Yeah,
Let's
I
hope
never
so.
hope
But
that.
I know you did that. No, no, never again. So, and then we have some other use cases like you have, of course, in finance, we have a lot of uncertainty. So, uh, uh, we could use the time series analysis for that. Um, and because it comes to the finance world, right? The markets are the purest form of temporal data, a ceaseless stream of prices, volumes, transactions reacting to the collective emotion of humanity. And every tick is a story of greed, fear, and momentum. Um, and for decades, financial forecasting was the test of discipline. Like arena models, moving averages, autoregressive factors, volatility clusters. Wow, difficult words this day today. And then suddenly the neural networks came and detecting nonlinear behaviors, correlations invisible to humans. And today, with the multivariate time series, we can integrate sentiment analysis, macroeconomic indicators, and even social media data to detect early signals. That we have that early warning system. Um, so imagine pairing stock price movement with Reddit activity, currency volatility pool with political polling, or consumer confidence with inflation's expectations. It's a lot we can do, right? We can create those early warning systems. And Click's time series engine complexity to the dashboards. How cool would that be, right? And it allows an analyst to explore cause and effect visually, not just the price trend, but what drives it, the interest rates, the sector indexes, the energy prices, the weather shocks, and so on. In finance, the difference between success and failure often lies not seeing the future perfectly, but seeing it slightly sooner. Time series forecasting narrows that gap from chaos to cadence, from volatility to vision. I still can't get that word right. Um, so if we go to manufacturing, Igor, the rhythm of machines. I know that. I did a project somewhere in the harbor of Rotterdam where we measured all those sensors, IoT, brought the data into click, did the predictions with another system than click predict because it wasn't there yet. And from there, we could predict the moment the machine needed maintenance. We could automatically send an order out to order the part that needs to be replaced and plan something in the agendas of the guy that needed to fix the machine. Super cool, super cool. Yeah. So and even in with the machines, we need to the IO data to come out and do predictive maintenance, right? Also, an early warning system helps to be predictive, to do the maintenance in the machine so that the time it's out of order is because you will lose money. So I'm I think we are at the end of this section, right? In machine learning, time series analysis in healthcare, in finance, retail, I think those five use cases are super intriguing and super interesting for people, right?
Absolutely, absolutely. So, in the organizations that thrive in the coming years will be those that understand temporal intelligence. So, the ability to perceive not only where you are in time, but everything else is headed. Like we going from dashboard to navigation systems. I said that when we were doing the adoption episode. So because the competitive
Yeah,
frontier, has shifted in
absolutely.
very recently the last time. So it's no longer about the spread of your data pipeline; it's about the horizon of your awareness. How well in advance can you know something that will happen? So how ahead can you see? How fast can you act? How confidently can you adapt? So time series forecasting, especially when made accessible through Click Predict, because let me tell you, if you have to actually program that, it's a lot of work. And so that actually extends that horizon. It gives every decision maker a glimpse beyond the present moment, a chance to act before impact. It's like your data DeLorean. So that's the heart of this episode, like moving from forecast to foresight. Because forecast describe what might happen, foresight prepares you when it does happen. So in the
Mm,
end, all data is temporal. Every number, every trend, every transaction has a timestamp, a position in the flow of time. So the challenge is in collecting is understanding its rhythm. So time series forecasting, empowered by tools like Click Predict, as we mentioned a few times before, is the art of turning that rhythm into readiness, the ability to sense the approaching wave in the year before it hits. So is the transition from watching the clock to navigating time itself. It perhaps is the highest form of intelligence, not to control the future, but to meet it prepared, to be prepared for the future. That's our journey for today. That's
yeah,
our episode for today. Our
yeah.
listeners, our data explorers, keep questioning, keep learning, and keep navigating the story behind the numbers. Jalika, thank you so much. When this episode is released, we'll be together in person in Lund, Sweden, where Click started, where everything actually started. And guys, let me tell you something. I'm not gonna tell you exactly why. No spoilers, but we are preparing a few episodes there in Lund in person with some amazing people episodes, and not only podcast episodes, other type of content for Data Voyagers as well. So stay
Exactly.
tuned. Make sure you follow us in social media and all of that. So then we know what we are doing next.
Yeah.
Thanks, Angelika.
Yeah. To close down. Yeah, to close down, man. I really like that you just mentioned from forecasting to foresight, because I think that's the movement where we need to be heading to, and it's all possible with Click Predict, right?
Yep,
It's possible.
exactly.
It's there.
Yeah, if you have Click Cloud, take a look
And
at it.
it's
Yeah.
not yeah, it's not only exclusively for data scientists. If you know your business well, if you can form your questions, you can actually do it yourself, right?
Absolutely. So thanks again.
Thanks,
Thanks
man, for
everyone
today.
that
Yeah.
listened to it. Make sure to subscribe to our forecast. See you next time. Ciao, ciao, pessoal.
Doei allemaal.
Data